Hey everybody, today we're diving deeper into machine unlearning. So in the last video, whichever side it pops up on, you learned about machine unlearning definitions. And what machine unlearning tries to do is it tries to allow us to unlearn specific parts of information in the machine learning model. So you can use this for privacy concerns, you can use this for security concerns, or even ethical and unwanted content concerns. It'd be pretty cool if it works. So let's take a look at how we do machine unlearning. There's some early unlearning methods. So the first well-received paper on machine unlearning was in 2015, and it was using statistical query models. So basically, these models already take a data subset, they create some sort of aggregate function based on that underlying, again, numerical data or non-numerical data that's been converted into numerical form. And then those features, those kind of aggregate features, get put into the model itself. So this is not anything like today's deep learning, but with this statistical query learning, what they were able to show is, look, if you do it like this, then what we can do is we can remove a portion of this subset, or we can recalculate that aggregate. And as long as that doesn't significantly decrease model performance, we can unlearn really easily. I mean, we don't really even have to do anything. We have to maybe rerun one query. If you have a simple model, like let's say you're using a random forest or something like this, you might take some inspiration from this type of setup and figure out if there's a way, instead of using direct data inputs, that you can use aggregates based on some underlying distribution of the data. There's another way to think about unlearning. This came a little bit later, so now we're 5 years later. And this is by changing the way that you train and compose the model. So in this example of sharded, isolated, sliced, aggregated learning, or SISA learning, what they did first, and this is brilliant in a lot of ways when you're dealing with low quality data anyways, is to shard the data first. So then you have these shards. Then they train a model. Each model represents a shard of data. Those models are put together in some sort of ensemble at the end for an inference aggregation, or perhaps there's even a layer at the end that connects the inputs to the models that you want to train to some degree or optimize. And then what they do with each of the shards is they also relate checkpoints. So as I'm training the different epochs, I say, okay, checkpoint 1 had this data. Checkpoint 2 had this data. Checkpoint 3 had this data. And what you can see here is, because we've kind of created this decentralized type of training, we can then say, oh, you know what? The data we want to remove is in shard 3, checkpoint 4. So that means we go to model 3, we roll it back to the model version that we have at the end of checkpoint 3, and then we continue training minus that data. So the worst that happens is we retrain a whole model. The best that happens is we retrain from a particular checkpoint and only one model. So this is kind of, if you're using, again, not today's largest models, but maybe medium-sized or small-sized models, you can perhaps also take inspiration from this. So let's say that you want to learn from the direct data. Can you save checkpoints along the way? Can you save the model versions along the way? And can you develop the proper governance to know what data went into what shard, went into what checkpoint, went into what model? So perhaps this is inspiring or instructive for some people on how can you then unlearn or remove that data. And then we're going to go into now what I call deep unlearning. So for large deep learning models, or even if you have a good deep learning setup at work or at home, whatever it is you're doing with your deep learning, perhaps these make the most sense if you have data mature deep learning infrastructure. Because basically, when we have a deep learning model or an AI model, right, and we want to unlearn, what we're going to do is we're just going to keep training. And I'm going to show you how we keep training. So perhaps we've reached some point, the model has been released, then comes in either a series of deletion requests, if we're talking about GDPR, or a series of outputs from the model that we don't want anymore. What are we going to do? We're going to try to unlearn those by taking that model and training it further. And this is really the promise of unlearning, is that I can train the model further so that it doesn't do those things. How do we do that? Well, first we have to identify a forget set. These are the data either that we want to remove based on privacy or security or ethical concerns. We choose that forget set. Obviously, it's extremely useful if we can be really good at choosing this forget set and make sure that it truly represents what we're trying to forget. And don't forget, in the forgetting video, that this depends on task complexity, model size, data complexity. So if we're trying to unlearn something that's a really complex, fundamental part of a model, we're going to have to do a good job defining our forget set. Once we have our forget set, usually we're doing gradient descent. So here's my loss landscape. Imagine it's in high dimensions. I am not a good artist. Imagine it's in very high dimensions. So just in your brain, try to imagine perhaps thousands or millions of dimensions. And we have space that we probably can't even imagine, but if this could be some sort of plane, and it's the loss landscape, so this is loss, for the forget set, I'm basically going to maximize loss. I'm going to ascend the gradient of that loss method. So I want to say, be really bad at this forget set. I want you to get everything wrong in this forget set. That's essentially what we're trying to do when we're unlearning. Now, as you can imagine, if you've been doing deep learning for any period of time, you're thinking, Catherine, isn't this going to create some instability in my model? Because normally we're trying to minimize loss. Now you're telling me we're trying to maximize loss on a subset. Yes, but yeah, you're right. That can be dangerous. So some other approaches also select a retain set. And this retain set is information, hopefully somewhat intertwined with your forget set. As in, let's say your forget set is a particular class. Let's say you want to forget about cats. I don't know why you'd want to do that, but let's say you have to forget about cats. Well, perhaps in the retain set, you have lions or something like this, if that's what you want to retain. So you want to try to think from an information theory perspective. Check out my information theory video. Think from an information theory perspective. What information could be intertwined with this forget set that I absolutely want to retain? Or if you can't do that well, then choose a retain set that tries to be representative of whatever the task or population is that you're mainly using the model for, right? So you have your forget set, your retain set, and something like a DPO setup. So what does that mean? Basically, you're going to try to find a balance between maximizing loss for the forget set and maximizing retention or minimizing loss for the retain set. And so you're going to either create some policy-based approach, which is what DPO uses with a policy model, or you can create essentially some sort of loss equation that takes both of these into account. This is still highly debated in research. What is the exact best way between these two? But there's many different approaches that you could try out there. And then finally, some other interesting research is thinking about taking the forget set, and instead of just maximizing loss to nowhere, you essentially introduce pseudo labels and outputs. And these pseudo labels and outputs allow you to say, this forget set doesn't actually have the label of cat. It has the label of animal. This is how you can think of this. Obviously, that works better for some model and task designs than others. For when you're thinking about language, you might say, okay, we're going to choose some generic nouns or generic words to replace a person's name with or to replace a concept with. But as you can imagine, then you're introducing essentially new information that may or may not represent what you actually want the model to learn. And so What are the challenges of deep unlearning and in general of unlearning the way that we do it today? Obviously, still a lot of the work is in research. And when we think about how we build these systems in production, what I wonder, having seen the machine learning production setups I've been able to see in my career, is can you actually easily define, forget, and retain sets? Are you able to easily segregate what you should forget, either if it's based on privacy concerns or security concerns? Can you actually define that well, given the training data setup that you have? And how might you actually define retain sets? Because if you're actually trying to do deep unlearning in production, you should probably try out more than one method, which means you're going to also want to try out the methods that use retain sets if possible. What we know from things like deletion requests is deletion requests are not equally distributed. It's not a random uniform setup. And that means there's going to be more deletion requests from some industries versus others. And B, let's say you have a security incident or an acquisition at your company, there's probably going to be over time a different distribution of deletion requests or data expiration periods that happen due to events that happen either in the news or in the company history. And so you're going to run into scale issues, because every time you're going to unlearn, you're going to have to train further, you're going to have to test, and you deploy, right? And so each time you're doing this, each time it's meaning that a person is in charge of overseeing this to some degree, and perhaps even experimenting with new unlearning methods. If you're trying to do this, once a week, maybe that works. If you're doing this in batch and you're trying to unlearn larger and larger percentages, so let's say you're trying to unlearn 10% of the data, that's going to be a lot different than if you're trying to unlearn 1% of the data, just from a model utility perspective and also from a training time perspective. And in comparison, how often do you actually retrain yourself? So large AI vendors are already retraining and re-releasing, let's say, every 3 or 4 months, a new model series. If you're already retraining from scratch and you know what you want to forget, you can just remove it from the training data. You don't need to bother unlearning. You could just retrain from scratch. Now, that's the question, is that actually economical? Is that efficient? Is that what we want to do? It's probably the best way to ensure that that data definitely doesn't exist in the model and that the model retains whatever utility exists in the other data. However, I hope that unlearning gets more knowledge and experience over time that we can better actually estimate what's more efficient over time. To properly define unlearning, and again, the last video on defining unlearning, you should check out, you need to also be able to run privacy auditing. And at this point in time, most places that are doing deep learning don't really have the experience in doing privacy auditing. That's why you're here. I'm going to show you some ways to build up your skill set around that. You can definitely also check out my book. But this knowledge of how do we actually audit the models appropriately so that we can say, okay, the risk is at this level, we think, for something like data exfiltration attack, then you can properly decide at your workplace, is it worth unlearning or not? Should we retrain? Should we unlearn? Should we do something else, guardrails or something like this? And then you're always in security and privacy, you're trying some sort of combination of approaches, some sort of mixture of what you think is the best for the risk at hand. So whether it's leaking somebody's data or whether it's dealing with the amount of deletion requests that you have or whatever it is, right? And you're going to try to find that combination with what you need the model to do, which is maintain the high utility of the model. And so if you do this at your workplace, you're probably going to learn that this is a learning lesson for you as much as it is a learning lesson in the deep learning space. I'm curious if any of you have tried doing unlearning already in your setups. I'd be curious to hear your experiences. And I'm also curious to hear, what do you want to see in terms of unlearning? Because I'd be happy to prepare some notebooks for us to go through and show you in a Jupyter notebook or in code how this actually works. So looking forward to your comments and questions. See you later.